Good morning, everybody. Today we're going to continue working with circles. We're going to be talking about central angles and arc measures. So a lot of you guys are a little bit confused on the difference between central and inscribed angles, and like I said, that's okay. We just went over the vocabulary in the beginning of the unit, and we're going to go more in depth with something new each day. So today we're going to talk about central angles. So a central angle is an angle with its vertex at the center of the circle. Okay, so vertex is at the center of the circle. And its two sides are radii. And that's just the plural of radius. The sum of all the central angles in a circle would be a full rotation around the circle, which is 360 degrees. Okay, so for example, in this circle, we have radius BA, we have radius BC, and B is the vertex of that angle, which is the center of the circle, okay? So the name of this central angle, remember, you always have to put the vertex as the second letter. So this would be angle ABC, or we could call it angle CBA, but that would be the central angle. Okay. Now we have a relationship between the central angle and the arc that is formed by the endpoints. So when I say the arc that is formed by the endpoints, I look at my endpoints of my angle, which are A and C, because again, B is the vertex, so it's not the endpoints. And then I just look at the arc that's formed between these 2 points. Okay, so the degree of the arc formed by the endpoints of a central angle is actually equal to the degree of the central angle itself. So the measure of arc AC is 84 degrees because that is the same amount as the central angle ABC. Now they're asking us next for the measure of arc ADC. So remember, ADC, 3 letters. That means it's a semicircle, which is equal to half of the circle, which is 180. Or it's an arc that is bigger than 180 degrees. So to find angle ADC, I follow the order of the letters named. So I go from point A to point D, and then all the way around to point C. So point A, next I have D, and then C. Now, since we said the measure of the entire circle was 360 degrees, the way that we could find the measure of that green arc, which is arc ADC, is to do 360 minus the yellow arc. So we could do 360 minus 84, and that gives us a total of 276 degrees. So this arc would be 276 degrees, okay? All right, we're going to do a couple of examples, and then you guys are going to work on the other ones and check your answers with the video. All right, so we'll just do the odds together, and then you guys are going to try the rest on your own. Okay, so find each angle and arc measures. All right, so let's take a look. We have central angle J and K. So if I follow the arc created between those 2 endpoints, that arc would also be 21. Then we also have central angle M and L. So if I follow the arc that's created there, that arc is also 21 degrees, okay? Because these are vertical angles, so they are congruent, okay? All right, so next we have another central angle. We have angle KNL. So if I could find the measure of angle KNL, then that's going to give me the measure of arc KL. And then it'll also give me this arc and angle on the other side because these are vertical, so they are congruent as well. All right, so in order to find the measure of arc or angle KNL, you might realize that KM is a diameter. Since KM is a straight line, that's 180 degrees. So to find this angle, KNL, it creates a straight line with a 21-degree angle. So we could do 180 minus 21, and that gives us a grand total of 159. So this arc is 159, and this arc is also 159. Okay, so now we can go through and put our answers in. The measure of arc JK. Let me get a highlighter out here. All right, the measure of arc JK is 21 degrees. The measure of our angle JNM, we said is that 159 degrees. The measure of arc KL is 159 degrees. The measure of arc JKM, so we're going to follow the order of those letters, J, K, and all the way around to M. J, K, and all the way around to M. So J to K is 21, K to L is 159, and then L to M is another 21. So we could just add those three arcs together, and we end up getting 201 degrees. And then we have arc MKL. So again, we're going to follow all the way around. M around to K, and then back around to L. So you could look at this two ways. You could add 159, 21, and 159, or you could realize this is almost the entire circle with the exception of 21. So you could do 360 minus 21, and that gives us 339 degrees. Okay? All right. Next, the only information we're given, we have this central angle CHD. So that means this arc is 90 degrees. Okay? Then they give us this arc FE. That means this central angle FHE is 34 degrees, okay? I usually only label either the arcs or the angles because if you label both, it starts to get really messy. I prefer to label the arcs because you have more room on the outside of the circle. So I'm not going to label this angle in here, okay? I know that it's 34 because the arc is 34. Okay, so let's figure out what we can do next. So I'm looking and I'm seeing, all right, GHC creates a right angle with DHC, okay, or they create a straight line back to back. So since CHD is a right angle, GHC also has to be a right angle. So this arc is 90, okay. Same deal over here. DHE is back to back with that right angle, so that one's also 90, okay? Now, we could add up 90, 90, 90, and 34, subtract that from 360, and we get 56. Okay, so that is 56 right there. All right, so now let's find our answers. So the measure of arc CD from C to D would be 90 degrees. From F to D, let's see. All right, so F to D. Now, if it's only two letters, it's a minor arc. So this is where stuff can tend to get a little bit tricky. Let me erase a couple of things here so I can show you what I'm talking about. Okay. So they have two letters. That means this is a minor arc, all right? So if we look at this, we could follow F to D in two directions. I think a lot of people tend to just go clockwise because that's what makes the most sense. But if we follow F to D in the clockwise direction, that arc is bigger than 180. So that can't be arc FD because it's bigger than 180. So I actually need to follow it this way because I know it's two letters, minor arc, has to be less than 180 degrees. Okay, so therefore, since I'm following it this way, we're going to add these two arcs together, 34 and 90, and we get 124 degrees. All right, next we have DCF. So again, we're just going to follow in that order. D to C to F, D to C to F. So I need to add 90, 90, and 56. Once I do that, I get a total of 236. And then last but not least, we have GDF. So I'm going to follow G to D and then all the way around to F. So again, this is almost the whole circle with the exception of 56. So we could do 360 minus 56, and that gives us a total of 304. Okay? All right, so I want you guys to pause the video and try numbers 2 and 4. Okay, so you guys are going to be able to check those a little bit later. I will make a separate video showing the answers for the practice problems so you can have some instruction on how to check them. All right, so next we're going to try a couple of problems involving algebra. So find each value or measure. Okay, so we're solving for the variable. So what I have here is I have this arc labeled as 15x minus 26, and I have this arc labeled as 26 degrees. Okay, now if we look at these two arcs together, so if I follow them together, they create a semicircle, which is half of the circle. And I know that they create a semicircle because RT is diameter. It goes straight through the center. I also know that a semicircle is equal to 180 degrees. So I can set up an equation adding my two arcs together and setting them equal to 180. We can go through and we can solve from there. And we get x equals 12. All right, next problem. I have this arc labeled, arc AD, and I have arc BC, okay? So I don't know anything about arc AB or about arc DC, all right? And these two arcs don't create a semicircle. However, if you look at their central angles, so I'm just going to kind of trace over their central angles here. I have angle AED and angle BEC. Those are vertical angles, which means that they are congruent. So if the vertical angles are congruent, that means the arcs that they create are also congruent. Since they're congruent, we can set them equal to each other and we can solve. Negative 34 equals negative 2x. You could have gone the other way. I'm not sure why I usually don't make negative variables, but for some reason I did. And we get x equals 17, okay? That's not our final answer though. This one is asking us for a bunch of info. So since x equals 17, we're now looking for the measure of arc AD, and I know that this is the measure of arc AD, so I can just sub that back in, 8 times 17 plus 12, and I get 148 degrees. Arc CD would be this arc right here, and I know that that is just going to be 180 minus arc AD. Okay, so 180 minus 148 gives me 32 degrees. And then last but not least, they want to know the measure of arc BDC. So again, we have to follow in that order. It's the entire circle with the exception of arc BC, which I know to be 148. So we could do 360 minus 148, which gives me 212 degrees. Okay, All right, so I want you guys to try numbers 2, 4, and 6, and then you can check back for the answer key on that. I'm going to post a separate link, which is going to give you the answers to those questions. As always, if you guys have questions, just shoot me an email. We will continue with this lesson tomorrow or next class, whenever our class meets. Let me know if you guys need help with anything.